Good morning, everyone. Thank you very much to be with us. I know that this is the only planned talk not happened on Wednesday, so I suspect that this change of a habit created, probably, an issue regarding your participation. But for the participants over here, I appreciate your contribution and participation in this last last online session regarding these talks, because more online sessions have been planned for you, and you should visit the website. In the website of the online talks also we have placed the link of the overall link of the activities that our colleagues in CUAS, in Carinthia University of Applied Sciences, have planned. And I can see also Carmen has already placed the link for you to be there. So today, last but not least, as they used to say, in this series of talks about doctoral studies and doctoral schools, it's a great pleasure to have us Professor Gunther Grabner from the CUAS, from the Carinthia University of Applied Sciences. Few words about the education of Gunther, if this is the first name, if I'm right. Thank you, Gunther, for the reconfirmation of this. He has a bachelor degree in medical information technology from CUAS, and then a PhD in neuroscience from Radboud University in Netherlands, if I'm not mistaken. Then he's a professor since then in CUAS, and also a director of 2 master degrees, if I'm not mistaken. One of them has to do with medical engineering, and the other one a master in healthcare. But today he's going to talk to us about doctoral program in brain diseases and tumors. And as far as I know, at least until recently, the study of the brain, it was one of the flagship research areas of Europe, which means the highest priority. It was graphene and also the brain. At the same year, they have been announced as the flagships of the research in Europe. So I think, Gunther, what do you represent? You represent something very hot, as they used to say here in the States, regarding the impact of the research and also the preparation of new scientists to support this research. So the floor is yours, and thank you very much for your participation.
Yeah, thank you very much for the introduction, and good afternoon. For us, it is already a bit later. As you said before, I'm professor at CUAS, and my work is basically focused on medical technology, and I'm responsible not for 2 master degree programs. It is 1 bachelor degree program and also 1 master degree program. Then on top, that is completely fine. I myself, I did the same bachelor program many years ago. Then I was 1 year or so in Australia, in Brisbane. Then I went to Canada, to Montreal. Then I started in Vienna at the Medical University. I did lots of my research in image post-processing and also image acquisition with MR, basically. And basically parallel to my work in Vienna, I did my PhD degree at the Radboud University in the Netherlands. So I will now share my screen. So you should now hopefully see my PowerPoint slide, basically. And today I will talk with you about our doctoral program, which is called Interdisciplinary Platform for Research Methods in Demyelinating Disease and Brain Tumors. And we basically focus on ultra-high field histology and also artificial intelligence. I'm the PI of this project at CUAS, but I do this project together with Wolfgang Bogner, and he is at the Medical University of Vienna. And the whole project is basically supported or funded by the Austrian Science Fund. So that is basically the biggest fund for that in Austria, I would say. And that is a special program because it is really designed to generate cooperative doctoral programs between universities of applied sciences and normal universities. And that is called Doc Funds Connect. So this whole application process was applied to this Doc Funds Connect. And the idea is basically that we establish and also develop this new doctoral programs between universities of applied science and the normal universities. And we really had to develop a new curriculum. We had, I don't know, to organize really everything basically around this program. What it is about, as my background is in everything what has to do with clinical imaging and brain research and so on. So in this project, basically, we try to bridge the gap between the basic brain research, right, where we develop new imaging protocols, where we try to find new markers and so on for some disease, and also the clinical needs. And the clinical needs, they are sometimes really different for what we people in basic brain research think that they are important to the clinicians. And in that project, we will use many different tools. So we use artificial intelligence. We use MR because we also work in the field of MR, augmented and virtual reality, and also lots of histology, right? Because you have to look into the small scale, basically, that you can find tumor cells and so on. And with that techniques or with this technology, we try to, as I said before, bridge the gaps between the basic research and the clinical needs. Here on that slide, I have two examples, basically, where we have our focus and so on. So the first thing is our brain tumors, and we can see here on the left, basically. So that is an MR image of a brain tumor, and within this brain tumor, we see all this dark spots, and these are basically blood vessels. And these blood vessels, they support the tumor with new and fresh blood, basically, that the tumor can grow faster and faster and faster. But some of these black spots, they are also blood, right, when it is bleeding inside and so on. And we really try to find markers which help us to better grade the tumor, because sometimes the medical doctors, they are not 100% sure what grade of tumor it is, how aggressive it is, what treatment plan we should use, and so on. And this is basically what we would like to increase here in this project. Here on the right, there is another example. So that is multiple sclerosis. So what we have in multiple sclerosis, we have inflammation in the brain, and this inflammation is normally the size, I would say, of a fingernail, roughly. Here, this is this enlarged lesion here. This inflammation is this bright thing here, and we see here all these dark stripes going through this lesion. These stripes, they are basically, these are blood vessels, and around these blood vessels, you see my mouse cursor, right? And around the blood vessels, we see these black dots here, and these black dots here, these are iron depositions. And we also see this iron deposition as some kind of a ring here around the lesion. And these are basically very important markers, because they will tell us about the progression or the clinical progression of the patients, right? So they are really important. So the more of the iron deposits we find, that we can say, the more aggressive it is, and the less iron deposits we have, basically, then it is not so aggressive. What kind of resources do we have in this project? So we basically have 1.5 million euros, and that mainly comes from the FWF, from this Austrian Science Fund, but also CUAS and the Medical University of Vienna, they contributed a lot on top of it. We have also in-kind resources, right? So we have really free access to really cool infrastructure, and also the personal costs are in-kind from the universities. So basically, with that 1.5 million euros, we can fund basically have 7 PhD candidates. And on top of that, right, so we will fund them, and then on top, we are able to send them to secondments in academia and also in industry. So secondments in our case means that we can send them 1 or 2 months to universities all over the planet. I will show you then some partner universities that we have, or also to industry, right? That they can work in industrial partner and, I don't know, further develop, I don't know, some head-mounted displays and so on. We sent the students to international conferences and workshops, and we also have the money that we, and also the students, right, that we can travel between the CUAS and the Medical University of Vienna, and that is roughly, yeah, I would say 4 hours train. But yeah, overall, yeah, we need some money for it. Also, sometimes hotels and so on, because the people have to sleep and so on. Let's talk a bit about our infrastructure, and that is really cool. So at the Medical University of Vienna, right, because that is really huge university and they have really top infrastructure. We have the newest neuronavigation tools and software. We have the 7 Tesla MRI scanner. So that is, I don't know if some of you are familiar with this. That is really ultra high field scanner, very strong magnetic field. So we get images with very high resolution, very high quality, and so on. Then at the CUAS, we have our Smart Lab. Smart Lab is really cool because the students, I don't know if they have to build something, 3D printing and so on, right? Or all other machines. We have very huge lab for that, and they can really do a lot here. Then we have access to the Vienna Scientific Cluster. That is also important if we would need more GPU or CPU capacity to do all our calculations, basically for AI. Then we have this Gründer Garage, or it is called Founding Garage, right? So that is where we could help the students to build their own startups, because entrepreneurship, founding of startups, right? That is also a very huge focus, basically, in this project. And last but not least, also very important, we have this interoperative MR scanner in Vienna. That basically means that they do a surgery on a brain tumor, for example, and they in the surgery room, they have basically an MR scanner, and they can then check what they did. This is quite a huge project. So I would say that there are really many people involved in it. So it is 2 universities, and we have a senior and a junior faculty. So senior faculty, so that is basically the people you see here, are the people who are the main PhD thesis supervisors. All of them have habilitation. All of them have a long track record in research and so on. But we have also junior supervisors. And these are, I would say not only young scientists, all of them have already a PhD degree. All of them have, I would say, 3, 4 peer-reviewed papers. All of them have project experience also. So these are really the next generation of senior supervisors. And in this group, we basically supervise all the 7 PhD candidates. So at CUAS, as you might know, it is not allowed in Austria for universities of applied sciences that people or the students do a PhD program, right? So we have to do it in cooperation with the Medical University of Vienna. That means that all PhD candidates, that they are basically enrolled in the PhD program in Vienna at the Medical University, and that PhD program is called medical imaging. So basically, in this PhD studies, basically the students, they have to complete 180 ECTS credits, and out of this 180 credits, 34 have to be done in courses or propedeutic. And we split them half, so roughly half between CUAS and the Medical University of Vienna. That means that the students from Klagenfurt, they go to Vienna for courses, and the students from Vienna, they come to Klagenfurt to us and do their courses here as well. And for the PhD thesis, they get 146 ECTS credits. So if you have 2 universities, right, and many supervisors and so on, so for that we develop basically a supervision team. So it is a 3-tiered supervision per student. And we have here on the left side, we have the CUAS, basically, where we have the Department of Medical Technology, Engineering, IT, and also our startup garage. On the right side, that is the medical university. And there we have the departments we work together with, right? So we have the neurosurgery, they do all the surgery with the brain tumors, we have the radiology, and we have the neurology. And let's say for one student, right? So let's say student number 4, that is student number 4, where I'm the supervisor at Carinthia. We have a second senior supervisor at the radiology in Vienna, and we really work very closely together. But to each pair of senior supervisors, we have also a junior supervisor. And the junior supervisors, they should get experience in the field of PhD supervision and so on. They are always together when we have our SureFix and our meetings. And it is also important that we have the whole supervisor team somehow split into different disciplines, right? So in every team, we should have at least one MD, right, who knows exactly what is needed in basically for the healthcare. And we have technicians, right, who are, I don't know, programmers or good with AI or image processing and so on. So we have really a mixed supervision team. And on top of the supervision team, we have also a thesis committee. If something does not go well or something like this, that the students could then also ask, in worst case, at the thesis committee and I don't know, complain or find solutions for problems, which will hopefully never show up. If you have any questions, please just don't raise your hand or so, but you can please just interrupt me.
Usually we have the questions at the end, so the Q&A session, Gunther, is at the end.
Okay,
But,
also fine.
As you request.
Okay, also fine. Yeah, and overall, as I said, we have 7 PhD candidates. Here are their numbers. These correspond basically to projects. So we have 4 PhD students sitting in Klagenfurt, and we have 3 PhDs sitting in Vienna. So overall, we have 7, 4 in Klagenfurt, 3 in Vienna, and each PhD student has basically a team of 3 supervisors. I like to travel, and for me, this international exchange is very, very important. And also my colleague in Vienna, Wolfgang Bogner, he has the same opinion, and that's why we really try to give this program an international character on top. So we really encourage the people to go to international conferences and so on. We invite international speakers. We do research retreats. We send them to conferences, workshops, and also this secondments. So that is basically a conference where we attended. That was last year in Chile. We were in Singapore with them. The medical university has a symposium for PhD students. And then there is also this IC forum, which will happen in November this year, where I'm also as well in the organizational committee. And IC basically stands for Artificial Intelligence in Clinical Imaging. So these secondments, right? We try to send our students to international partners. And even when we applied for this grant already, we had already our international partners. So we had more than one international partners per student. So basically, and the students, they can then choose within this 3.5 years to which company or to which universities they go. And here are just some examples where they could go, right? From these universities, we have already these letters of intent that they would welcome our students for, I don't know, a few weeks or months. That they could come. But also the internal exchange is very important because we have half of the team in Vienna, half of the team is in Klagenfurt, and we try to really meet a few times a year, and then I don't know, we go hiking, we go out, have some dinner and so on. Bowling was in winter. That is really important, that the students, they know each other and that we really have short ways within the group. Another thing which is very important to us is entrepreneurship. I guess this is something where we should look a bit to, I don't know, to North America, where entrepreneurship is more important. It is on a higher level than it is here in Europe. and I would like to push it a bit. And we are really trying to do that. So we included basically entrepreneurship as a course in our PhD curriculum. So all the PhD students, they have to do one course about entrepreneurship, where they learn all the rules, what you need about funding and so on. And we also tell them basically that we have our smart lab and the Gründer Garage, this founding garage, where they can really try to build things. And if they would say that they would like to build a startup, then they would get very good support here at CUAS. So this is basically how the project is set up. And at the end, I would like to give you just 2 examples about what we are doing. So the first example, what we have here is that we try to create synthetic histology data. What is histology data for those who don't know? So if you have an MR scan, right? So these are basically these pictures here, right? So you go to the hospital, you go into the magnet, you take the picture of your brain, basically, and then you have MR images, and they look like these ones here, these gray ones. But histology, or let's say that these MR images, they are based on the magnetic property of the tissue, right? So the property gives you different contrast, and then you can see different structures in your brain. But for many diseases, it is important to have histological information, right? And these are these images down here. But for histological information, you need a tissue sample, right? So that you can't acquire from a living person. So so these images basically, they come. So we have a brain, really dead person. We take out the brain, then we cut the brain in slices, very thin slices, few micrometers. Then we put special chemicals on it, and these chemicals, they react. So here, this blue one is basically for myelin. This is on our nerves, basically. So if you have lots of blue, that is a good sign. And for some disease, if the nerves are destroyed, right, then this goes away, this blue goes away. And on the right here, we have staining for iron, because iron is also very important, a very important marker. And in this histology, you can really see the iron. And under the microscope, you can zoom into a really molecular level. And this is basically the ground truth, right? So this is the ground truth, because you really have the brain tissue. But you need the tissue sample. So that is what you can't get from a living person, you know. And then in this project, we try to create an artificial neural network. And in this network, we give the MR data and we give the histology. And we try then to create synthetic or virtual histology data. So basically, the idea is that we take MR data, put it into this AI network, and then get virtual histology data. So that is then something what we could have from living people, right? So you go to the hospital, you do the MR scan, and then with some AI magic, basically, we would get this virtual histology. So information on really histological basis. And this is actually something where we are now working on, and I hope we will publish the first paper quite soon. So it is mostly done. So we have here the ground truth, right? So that is the ground truth. So really the histological data from dead brain tissue, basically. This here is the zoomed-in version of it. And this here is the virtual one, right? So that one is created only with MR data. And we can also do that now from in vivo, that meaning from living people, right? So we put the MR data in and we get the histology data out. And here on the bottom row, we see the same for iron. So this is the ground truth in zoomed-in version. And this is here our synthetic or virtual reality. So that is basically done by Pitaya Ponsuthatip. So she is a PhD student from Thailand and really our AI expert and very good in that field. Another project we have that is for neurosurgical planning. So that is basically done by Anna Drexlerova. And how is neurosurgical planning done? So the MDs, the neurosurgeons, they sit on the computer, they see everything what is inside the brain on the screen, and then they really plan the surgery of this of the patients, right? And what we do in this project, we expand basically their workplace. So they have their computer as before, but on top, they can wear these AR or VR glasses, and then they can expand their workspace basically. So it is on the side of the computer and so on. They can look at the data in the virtual space, I would say. And this is basically how it looks. So this is a video. So you can see here the computer, and on top, this is now Anna having the glasses on, and she also sees this brain, right? So it is just projected into the glasses. She can move the brain, she can rotate it, she can look from it from different perspectives. So this is how it looks. And you can also look in a group of people, right, to the same data. And yeah, you can look at it and you can also look inside basically. And that is done here in this video, where we basically have this blue ball and you can move this blue ball, and then you can see here this red ball inside. So that is the tumor. And with the ball, you can basically go inside and outside the brain. And this is where the surgeons should then be able to plan the resection. And they should really know where are all the important blood vessels, where are the important nerves and so on, that they can do it really without harming the rest of the brain. So that was it from my side. I hope you got some ideas what we are doing in this project, and yeah, now it would be the time for questions.
Thank you very much, Gunther. It was very informative. What are you doing in your doctoral program? In this doctoral program, I have questions. Actually, I have more than one, but I will provide the floor to the audience first. Please stop sharing your screen, Gunther. Thank you very much. Any questions from the audience? Or I should start? Usually I count to 3. All right, I will start the discussion, Gunther. First of all, I mean, in this series of talks, we are discussing about doctoral programs and doctoral schools, and one of the main aspects of the doctoral schools is the multidisciplinary. So the reason that why do we develop, or I mean, at least this is one of the reasons, in order to create a doctoral school is like to provide a multidisciplinary, let's say, education or training, let's say training better, education and training to the PhD candidates in order to be more, let's say, to be able to adapt faster in the market needs and what the real world will request from them. So can you please identify or highlight a bit where this multidisciplinary exists in your doctoral program?
For us, that is also very important. You know, we have basically per PhD student, we have 3 supervisors, and that is an interdisciplinary team. So we have people working on the medical field. Let's say we have with multiple sclerosis, we have Dr. Asunta Dalbianco. She is a neurologist, so she is really in the field of MS for, I don't know, minimum 10, 12 years, I would say. And then we have me or Georg Langs, or I don't know. So you, as experts in the field of AI, or as experts in the field of image processing or MR image acquisition. And this is really what the students have to learn. And Sutadip, so she is the one who creates this artificial histology. So she sits normally in Klagenfurt, and we do all this image processing and apply all this AI stuff. And now for, I don't know, for 2 months or so, she is in Vienna. And that is also this interdisciplinary thinking, right? So she is now in the lab there, and cutting all the brain slices, doing all this histology, this painting or the staining of the tissue and so on, that she really sees everything, right? That she is not, I would say, not only the AI expert, that she is also the one who knows, I don't know, how a brain really looks, what do you have to do with the brain, right? That you can do all these histological investigations and so on. So that is really, I would say, a big bonus in our project. Yeah.
Yeah, thank you very much. I mean, now I think that it was a bit naive, my question, because now all the disciplines are multidisciplinary. Mainly, one aspect would be, the AI impact and introduction to them. But, as you said, you are from the medical, it's around medical field, and multidisciplinary is by definition different specializations from the medicine. However, I would like, a bit more light. You mentioned that 34 ECTS correspond to the courses. So within the courses, does this multidisciplinary reflect?
Yeah. We have courses, so half of them are at CUAS in Klagenfurt, and here we have, for example, the entrepreneurship, because we have our founding garage is very good, right? And we really, I don't know, tell them about that. They learn academic skills, how to read papers, and so on. They get the basics about AI. And in Vienna at the medical university, right, it is more medicine based, right? So we are more on the technical part, and they, because they have all the MDs there, the focus is more on that.
So Gunther, at this point of view, in HMU, at least, our team in the Department of Electronic Engineering, but in general, within the university, I represent the university myself. We have started to introduce with COILS these research skills, and this type of courses, like how to write a paper, how to evaluate a paper, how to submit a proposal, and we would like to move now from a COIL to more face-to-face activities. So I propose that we can create a joint course in this field between at least HMU and CUAS. I will travel to CUAS, after my return from the States, in order to discuss more things of collaboration. This is the agreement with your rector. But I will say that it will be a joint course, and people and professors from HMU can come and teach within this program, and the vice versa. This is a proposal. This is one proposal, and the second proposal you mentioned about entrepreneurship, and I think that we have a very good entrepreneurial team that they are doing a lot of nice things in HMU from another department in Agios Nikolaos. They are doing hackathons. They work together with big companies. So I will say also this could be a place in order to do a more joint activities. And why joint activities? Why do I propose this? Because joint activities, they will promote and sustain the mobilities between professors and students. So students of HMU, for example, they are going to be interested in your program, and vice versa. I will speak with Carmen and with you in order to move on and have to make it materialize, unless, of course, you have strong disagreements. But this is something that we can discuss.
I would be very happy if you would come and, I don't know, and tell the students here how important entrepreneurship and all this startup community in the US is,
Yeah, definitely I will plan this. And I will plan some sessions also from here, from the US, because the entrepreneurship here is like by definition. You don't have to mention entrepreneurship. This is how do they train, and you don't mention this. This comes as a library, as any university should have a library. This is something that has impressed me. The other thing that I would like to ask more information is about the duration of secondments. It's a 2 months secondment, or what is the duration of the secondment?
Yeah, so roughly. So that is not 100% fixed. I guess it will, I don't know, be different for every student. So we can support them with a few €1,000 that they can go there, pay the flight and accommodation. But I guess it will be different for every project. But I would say on average 2 months.
2 months. Okay.
Yeah.
All right. And then, and my last question, and I think this is my last one. This is more from political point of view. Since, the industrial PhDs are already, at least in the Central Europe, for many years. In us, it's something that has been introduced the last 2 years. The Hellenic government would like to promote, but not so constructively, I would say. Why the University of Applied Sciences, that they are so close with the industry? Because this is the purpose. I mean, you create University of Applied Sciences like in Villa that you have next to the semiconductor industry. So why they cannot provide PhDs? This is from the moment that this can be industrial PhDs. This is something that I cannot understand. What is your perception?
Yeah, I mean, it is. The problem is that it is just not allowed, So, so we have students at CUAS, and they do PhD for companies, right, for Infineon and so on, but they have to do it at the university because only the universities can give the PhD degree.
But this is very strange. Contradicts why University of Applied Sciences are there, and why they are there is like because of the links with the industry and the market. I mean, this is an old perception before 10 years or 15 years that probably the professors that they teach in the University of Applied Sciences, in some cases, they could not have PhD degree, but this has been changed because of the competition and the quality. So for me, it's very strange that it still happens.
Yeah, I mean, I hope that will change in the next future. But it is also important, in Austria, we have this habilitation. You have to know what habilitation is. So basically that is on top of the PhD. And of these people, we don't have so many at CUAS, for example, right?
Can you give us more information? Because in Greece, we don't have rehabilitation as this terminology, under this terminology. Can you please give for our audience a very brief description of rehabilitation?
Yeah, habilitation is basically, so you do a PhD and then you do your postdoc research and so on. And this takes, I don't know, I would say 5, 6, 10 years. And then you can apply for this habilitation. And for the habilitation, you have to show that you are good in teaching, that you are good in leading projects, that you have some supervision and so on, right? So that you are good in acquiring grants for some research and so on. So that is basically what you have to do. And then you have your habilitation. And then you are basically on the level where you can do a PhD supervision.
Oh, excellent. I will appreciate if you can share with me, this description. Carmen, if you can share with me this description about rehabilitation, because matches with some processes that we have now that I'm hearing what it is. But I think it's a good guide for us, if we would like to change some things in Greece.
So in Greece, you can do PhD supervision after some postdoc time, or?
Yes, of course. I mean, fundamentally, yes, there is no restriction. It should be a restriction. But in Greece also, we still have the old model of PhD studies 1-1. So the supervisor and the student. And, I think that this will be changed. And this is what, I think that what we envision, like to create a doctoral studies, doctoral schools, in order to provide these more general but very important courses, but also to secure the quality of the PhD supervision and the quality of our PhD students as well. So yes, it's a little bit, more relaxed, but this will be changed in a more organized, with the main objective, the higher quality of the PhD studies. This also relates the graduation of all the PhD candidates in a logical framework, but also what does it happen beyond the PhD? Because this is very important in link with the alumni connections and how many of them they can be linked with the market and with the university later. Carmen, yes, in Wikipedia I can find it, but I would like, what is the approach of the CUAS?
At CUAS for now, for the habilitation?
Yes.
That is not possible.
This is not possible because you cannot provide PhD. Yes, my stupid question. So I received my answer by myself, immediately. Thank you.
Yeah,
and I will use it.
Yeah, so if the researchers, if they would like to do the habilitation, then they have to do it at the university.
Excellent. So from my side, these were the questions. I don't know if anyone from the audience has more questions, more things to discuss. If this is the case, I would like to thank you again, Gunther, for the nice introduction. By the way, some colleagues of ours, they will visit CUAS, more than one. I think that there are going to be 8 or 9 from HMU to follow the face-to-face workshop about PhD supervision. and they will be very happy to meet you. But anyhow, I will have a follow-up of what did I propose in order to collaborate as a universities in these topics, like joint, let's say, courses, and later on joint programs under doctoral studies. So I would like to wish you to have a nice afternoon in Europe. For us, a very nice morning. And speak to you soon. Bye.
Thank you.
Yeah.
Some closing
Thank you
remarks
very
from
much.
my side, maybe
Bye.
just for the
Carmen, yes,
organizational
I'm
part.
sorry.
Just
I'm sorry.
to remind you, for the talks are now finished. So, but we have in February, so next week on the 18th, we have our last online topic. We have our roundtable. So very warm welcome also to join the roundtable. I'll send you the link directly for that in the chat. And otherwise, we will see latest in March here at CUAS. If you have any questions, please feel free to reach out to us. We are here for clarification. So thank you also from my side, and have a nice week ahead.
Goodbye.
To all of you. Bye.
Bye.
Thank you very much. Bye-bye.
Bye bye.